Hello, my name is Maria from mathmammoth.com. In this lesson we're going to be comparing functions. Here I have two functions depicted. The first one here is given as a table of values, and for the second one we have a graph. And both of them have a time here and distance as the two variables. Here's the time, here's the distance in meters. And so we are asked, which of the depicted functions has a greater rate of change from 3 to 4 hours? This one is a nonlinear function. This one, I don't know. We don't actually need to know that. It's asking for the rate of change from 3 to 4 hours. So from 3 to 4 hours, the time changes by 1, and the distance, the meters, changes by 7. It increases 7 meters per 1 hour. And then for this function, at 3 hours here, 4 hours here, so it is 30 meters and about 33 meters. So that would be, this here would be just 3 meters per 1 hour. So clearly this function has the greater rate of change. It was 7 meters per hour. So it is this one, but we can write the numbers here. 7 meters per hour versus 3 meters per hour. Then, which of the depicted functions has a greater rate of change from 2 to 3 hours? Solve that yourself first. Pause the video and try it yourself. So from 2 to 3 hours, it changes by 7, from 14 to 21. It increases by 7 meters in this 1 hour. So let's write it down here. And then this other one, 2 hours, it is at 20 meters, 3 hours here at 30 meters. So there's an increase of 10 meters in that 1 hour. So therefore this function has now the greater rate of change here from 2 to 3 hours. All right, let's go on. Now we're going to compare these two functions. Try this again yourself first. Which one has the greater initial value and which one has the greater rate of change? This time function 1 were given as an equation. Function 2 were given as a graph. And so y equals 8 minus x. Now this is a linear function. I want to show you that it is by rewriting it like this. Y equals minus x plus 8. Now it looks more like the familiar y equals mx plus b. Remember? Here we have the initial value is 8. And then m, what's m? It happens to be minus 1. Minus 1 times x, okay? So the rate of change for this function is minus 1. Well, what about for this one? What is the rate of change here? We need to calculate it. Let's take 2 points at the grid lines. Here's one. Here's another. And so our input values are changing by 1, from 0 to 1. And the output values change from 9 to 8, right? That's a decrease. This function is decreasing. So a change of minus 1 over 1. Which is just minus 1. So actually both functions have the same rate of change, minus 1. And which one has the greater initial value? Oops, I skipped that. Let's go back to it. Yeah. Here we already determined that the initial value was 8. You can also see it by plugging in 0 in place of x. And here, at 0, the initial value is 9. So function 2 has the greater initial value, 9 versus 8. And which one had the greater rate of change? They're the same. Or you could say neither function has a greater rate of change. All right. Do these two depict the same function? And if not, which one has a greater value when t equals 50 minutes? This function is given as a graph, lots of points. Again, we have time on this axis in minutes and distance in kilometers here. And here we have time and distance again, and these values. do these depict the same function? They both start at 0, 0, okay, and at 5, here's 5 minutes and half a kilometer. These two values are the same. One thing I notice is that these time values go by 5 minutes here, and the distance here increases each time by half a kilometer, okay? So this is a linear function, okay? Each time the increments are the same. But this is not a linear function, because it goes kind of curves here like that. It's kind of linear here, maybe, linear here, but not all the way through. So they are not depicting the exact same function. So therefore, which one has a greater value when t is 50 minutes? T is 50 minutes, 5 kilometers. 50 minutes, this one is less than 4.5, maybe 4.2, 4.25 kilometers. So this particular function has the greater value. All right, well done. I hope this was helpful.